So now we're looking at section 9A, independent and dependent variables. In this section with the independent and dependent variables, these are what makes up independent and dependent variables is the basic crux of what makes up a linear function. And linear function will be our focus in our next section. So this is getting you ready for our linear functions. So let's get started here in example 1. I'm going to work through basically the first page and about half of the second page, and then I think you'll hopefully have a good understanding of what's going on here in this particular section, getting you ready for the next section. So it says here, the value of a car depreciates over time. A car that was originally worth $25,000 experiences a depreciation of $1,000 per year. As we talked about in section 8A, you should recognize that this exhibits what kind of decay, linear or exponential. And since it is a fixed value, $1,000 per year, we're going to go with linear. Okay, so that's what you should have by now. Because, and I'm just going to write this out, I'm not going to write this out, you can see it there on the solution key, because it's decreasing by the same amount each year. It's not a same percentage, it's the same amount each year. The next piece down is the formula that would be used to predict the value of a car over the next few years. This type of formula that you see here is something that's being given to you right now, but in the next section we're going to learn how to actually create these models for our data. So in the formula, what do you presume that V stands for? I tried to make variables that made sense in terms of the context of the problem, so hopefully you'd recognize here. Well, V would just stand for the value of the car. And then the A is going to stand for, hopefully you'd recognize, the age of the car. And it's probably important that, since you're talking about the age, to clearly define, okay, we're talking about age in years. We're going to need to be able to discern what type of variable they are. Are they independent or dependent? Because that's going to determine what a graph looks like, which one goes on the x-axis, which one goes on the y-axis. And don't worry if you're not sure about what I'm talking about, x and y-axis. I'm about to talk to you all the way through that. But those of you that have some prior knowledge about linear functions, then you already know what I'm talking about with x and y-axis. So just to go ahead and jump right into x and y-axis, whenever you're looking at graphs, the horizontal piece down here, that is always your x-axis. And the vertical piece, that's always your y-axis. We start here with dependent variables. Basically, this is the variable that depends on the other variable. Some characteristics of dependent variables. It's the variable plotted on the y-axis. All ordered pairs are always x, comma, y, you may recall. So whatever's being plotted on the y-axis is always going to be your dependent variable. It's the second entry in an ordered pair, because obviously if y is the second entry there, it's going to be plotted on the y-axis, then that dependent variable is the second entry there. It cannot be controlled or manipulated. It's a clear response to whatever you input, whatever variable we're going to be inputting our independent variable here on our x-axis. This is going to be a way to help you figure out which is independent and which is dependent. And a trick is that, find the dependent first. It's filling in this little sentence, and I have it written here as blank is dependent on blank. And whatever goes here in this first blank will actually be the dependent variable, i.e. what's actually going to go on your y-axis. What are you measuring on that y-axis? So in our car example, we've got value and we've got age. We've got the value of the car and the age of the car. So ask yourself, which way makes sense? Is the age of the car dependent upon the value? And if you say that to yourself, the age of the car is dependent upon the value of the car. That does not really make sense. But if we flip that around and we say that the value of the car is dependent upon its age, that makes more sense. That the value of car, a little shorthand here, is dependent upon the age of car. Clearly then I have, that hopefully that does make sense to you, that the value would be dependent upon however old the car is, because obviously as the car gets older its value is depreciating until it becomes an antique. However, if we turn that phrase around, like I said before, it's not going to make any sense to you. So here, whatever is in that first blank, that's your dependent variable, what's going on the y-axis. So here, then, the value is my dependent variable on my y-axis, and my independent variable then is the car's age, excuse me, which is going on my x-axis. Okay, I'm going to draw you a graph, and actually let's just go ahead and draw that graph. So what we're saying then here, let's use a different color. What we're saying then here is that along this x-axis is going to be the age of the car, and along the y-axis is going to be the value of the car. And we know initially at time 0, when you first drive off the lot of this car, it was worth, what, $25,000? Yeah, that's what we were set back up here. It was worth $25,000. So I'm just going to put a dot up here. And every year after that, it's decreasing $1,000 per year. So going down like so. So that every year, it just keeps depreciating, okay? Independent variable is what's being plotted on the x-axis, as you can see here, the age. It's the first entry in your ordered pair. It makes sense. Ordered pairs are x comma y. So if it's on the x-axis, then your x is always your first. It can sometimes be controlled though. You can determine, hey, the age of this car is 3 years, or the age of this car is 10 years old, that sort of thing. But like I said, you generally want to find your independent and dependent variable. Use it. Yeah, I find using this sentence is helpful. Some people like to think of it as cause and effect. Because of its age, then here is my effect. The value will be going down. Time is generally an independent variable, and it should be said it's not always, but generally it is independent variable. Don't fall into that trap. I would always recommend that you go through the sentence there. But find the dependent variable first, because if you go through the sentence, then the first blank there is always your dependent variable, what's going on the y-axis. So since you now know about x and y-axis and what's independent and dependent, if you look back up here at your notes, your independent is what's on the x-axis, dependent is what's on the y-axis. And so you can see here then, it's just asking, okay, what's independent, what's dependent? You can see then, here's my x-axis. Over here on the right, that's my y-axis. So on the x-axis, that's my number of oil changes. And then over for my y-axis, then I'm doing repair cost. Okay. We'll flip it over to the next page, and we'll work through example 4 and a couple of example 5. Okay, it says in example 4, it says if the number of hours a student studied for an exam in a math course are counted and the number of points that person earned on an exam are recorded, then the statement the blank is dependent upon the blank is probably correct. So I know that was a lot, sort of jumped right into you there. Let's figure out, okay, what two things are we trying to measure here? You can see here it's talking about the number of hours that they studied and then the number of points that they earned. So ask yourself what makes sense. Is the number of points dependent upon the number of hours that you study? Or is the number of hours dependent upon the number of points that you earn? And if you think about it, the first way I said it actually makes more sense, that the number of points earned, is dependent on number of hours studied. I apologize for the pen. My handwriting is not that bad. Definitely consult the solution key. So here then we can say that the number, whatever's going in that first blank, is your dependent variable. So the number of points earned is my dependent variable, and so therefore it's going to be plotted on the y-axis. The independent variable then is going to be the number of hours studied, and that's going to be plotted on the x-axis. So in these next few examples, I'm giving you, just some more opportunities to work through a couple of different types of variables and figuring out, okay, which is your independent and which is your dependent. You're identifying your independent and dependent variables. I don't write the sentence out each time, but I recommend that you, use that as your guide. The first blank, though, is always your dependent, always your y value. And the second blank's your independent. So here they're talking about ice consumption in pounds. So the ice consumption at a park compared to the temperature on a spring day. So we're talking about two things, ice consumption and temperature. So take a moment to think about that. Is the ice dependent upon the temperature, or is the temperature dependent upon the ice? And so hopefully you would agree that the ice consumption, how much people take in, that's going to be dependent upon the temperature. Because if you think about it, on a really hot day, more ice is going to be sold versus, on a really cold day, they're going to be selling hot chocolate and things like that. So here, remember, what goes in your first blank, that's your y value, that's your dependent variable. So ice consumption. And my independent variable then is my temperature. And if you were thinking about, I'm just going to give you a nice little precursor here where you're headed, thinking about then, okay, then what that means is temperatures down here on my x-axis, ice consumption is over here on the y-axis, and as that temperature increases, my ice consumption is going to be increasing. I didn't put any numbers down here on the temperature scale, but obviously it makes sense then that the temperature would be increasing from left to right. All right, and so let's do one more together. In part B, it says the number of powerboat registrations in Florida compared to the number of manatees killed per year. So you've got two variables here. The number of powerboat registrations compared to the number of manatees killed. So again, I didn't write out that, the blank is dependent on the blank here for you, but you can always say that to yourself, and you can always write it out for yourself. I know I wrote it on the solution key. But here, the number of manatees killed would be dependent upon the number of registrations that have been, given out in Florida. So since I said the number of manatees killed, that's what's coming first. That's my dependent variable. So number of manatees killed is dependent upon number of powerboat registrations. And I mentioned before, some people say this is a cause and effect. Your independent variable is always your cause, and here's your effect. So if that's a better way for you to think about it, for this problem, because you have a certain number of powerboat registrations, the effect is there's going to be a certain number of manatees killed. In the previous problem, the cause would be the temperature. Because the temperature is this high, it's going to have an effect that we're going to have more ice consumption. Okay? All right, I'm going to let you then work through the remainder of this set of notes. And again, I mentioned at the bottom, it's a clear cause and effect, which is your independent. Your cause is your independent, and your effect is your dependent. Do whatever works for you. It should be noted in the book that they ask you to do more than what you need to. You only have to identify independent and dependent variables. If you want some extra practice, and it probably wouldn't be a bad idea. It'd be really quick, easy practice just to try those 5 problems and make sure you can get good at independent and dependent before moving on to our next section.